Okay, this is vodcast 1.1 for AP Chemistry. Okay, this is the start of Unit 1. These are our objectives for Unit 1 up here in the corner. You can read through those at your leisure. Remember that the ion test that you took, we will have a larger one probably Friday, right, to get to that. But remember what chemistry is. Chemistry is the study of matter. Okay. And we are going to study chemistry and try to manipulate matter. Now, matter can exist in a couple of different combinations. And this is where we start talking about pure substances and mixtures. So if we look at pure substances can only be separated by chemical means. So you'd have to do a chemical reaction to break the chemical bond, so that pure substances. Now, pure substances doesn't mean like just oxygen or just copper, but it could be a compound such as a water, acetic acid, calcium carbonate. A lot of different things are compounds, but they're also pure compounds. And so we'll deal with those in class and in lab. So in looking at this chart, okay, you see pure substances divided into compounds, and into elements. Okay, so those will, and elements can also be divided into more smaller things, which elements are made up by atoms or compounds or ions. And atoms have a nucleus, they have electrons, and then nucleuses are broken into protons, quarks, neutrons, and quarks. All of these, this thing down in this area is nuclear chemistry, which we won't touch on much, or physics actually will go into more of that detail. So for now, we're just going to go with this particular aspect. So we're going to move on, and we're going to talk about mixtures. Okay. Mixtures, a little bit bigger. Mixtures can either be homogeneous or heterogeneous. Homogeneous means that they are the same composition, throughout. Okay, and some examples of homogeneous mixtures are copper. You know, actually it's not a mixture, but homogeneous mixture, that's a pure substance. Homogeneous mixtures like solutions, like milk, and those types of things. Okay, heterogeneous means that it's different throughout. And so a good example of substances that are different throughout is like a pepperoni pizza. Like pizza's different, you know, with different toppings on it. Like mixed nuts that you see in like you get planters and those kind of things that you eat. Those have cashews, almonds, those kind of things. Those are also different. Okay. Now we can separate mixtures, okay, but it's based on, the separation is based on a couple of things, either based on physical properties, and that's distillation, and then its example of distillation is up here. Essentially, you heat the mixture up, and then each of the liquid mixtures will boil at a different temperature. And so here is the mixture in this area, and what happens is the boiling points are different. So some of the substance boils off first, and then is condensed back, and you start collecting it. Okay. In terms of chromatography, that is used on, this is an example over here, and the solubility of the substances. And so essentially what you can do is make it dissolve and chromatography will separate the different substances. So if this black felt tip marker is separated, usually if it's permanent marker you have to use alcohol. Water can do this with non-permanent markers, and so what eventually happens is by capillary action the water that's in this petri dish, this is filled with H2O. Okay. Once filled in this paper, just goes up the filter paper, and by going up the filter paper it's separating the different dyes that make up the black mark. And so as you can see, you have different color ranges, different dyes that make up the colors, and so they separate differently on the page because the solubility of each are different. And so the ones that move up, and it depends on the characteristics, and that's why they're divided like that on the paper. Okay. Alright, let's move on. Now we're going to get into significant figures. This is an important question. Why significant figures? It's important for precision and accuracy. The one thing I can't do is I cannot add accuracy from any kind of computation. So I can't add, because I'm doing a calculator, I just can't add numbers to make it look like it's more accurate or more sensitive, the equipment. So I have to be careful with that. And so rules for counting significant figures are the follows. All non-zero numbers count. Leading zeros don't count. Trailing zeros count if there is a decimal, and trailing zeros don't count if there's no decimals. So examples of counting significant figures, so let's take an example of this. So if I have the number 1158, okay, all of these, this is rule number 1, all of these are all non-zero digits. And so each of these digits, the 1, the 5, and the 8, will be significant, so there are 4 significant figures. So now if I have 4 significant figures, then I will need to have those in my answer, or if I'm looking for 4 significant figures, they need to be in my answer. Okay. Now it says leading zeros don't count. What I mean by leading zeros is when you have a decimal, okay, 0.0015, these zeros here do not count. Okay, they're just placeholders, so they don't count as significance. And that's what you have to understand, is significant digits have to deal with the hard part is what are the zeros? Are they significant or not? In this case, since they are leading zeros, they do not count. And so essentially what I do is I go through all the zeros until I hit the first non-zero digit, and that is 1 and a 5, so I have 2 significant digits. It has nothing to do with the magnitude of the number or anything like that. It's just 2 is the number of significant digits that I have. Now, when I go on to 3, okay, the trailing zeros count if there is a decimal. So, for example, if I have 100.40, okay, this 0 after the decimal point counts, and so all of these zeros are counting because one thing that they left off is these sandwich zeros between non-zero digits. These are significant too. So in essence, I have 1, 2, 3, 4, 5 significant figures. 5 significant figures there. Okay. And the last one, trailing zeros don't count if there's no decimal. So if I have 10,000 whatever, these are just placeholders. And so in actuality, I only have 1 significant digit.